Hi, this is Jacob Nash with JNGL. Today we will be looking at Unit 1, Lesson 2, Segments and Rays. And I forgot to put it there this time, but it is standard 1.1. There we go. 1.1. So segments and rays. And that's not all we'll be talking about, but I couldn't find words to put in the other stuff. So, like last time, I'm using this Jamboard. And the segment is this one, and array is this one. And we'll talk about what they are. Segments. Segments are a part of a line consisting of two endpoints and all points between. So it has two endpoints. So it's not just like this time. It's going to be like this with two dots on the ends. And the segment can be inside of a line and even inside of an array, but there's just segments. So how do we name these? Okay, so we have an example right here of segment GH. So GH. Now we're gonna on the other ones when we did lines, points, and planes, it didn't matter what order you put the letters in. It does matter on some of these. But what you do is you put the letters of the segment that you're talking about. So GH. Now, if we're talking about just the line, remember we put the line symbol on top. So you can't do that if you're trying to talk about the segment. If you're talking about the segment, you put GH, line on top. Alright, good. That's how you name them. And with the two questions that you could be asked is if you get a question where it says two letters equals something and there's nothing on top, that means it's asking you what the measurement is. So the measurement would just be 180 degrees because that's just what it is. And then, well, that's what it is if you're talking about the angle. But if you were talking about like inches, then you would just say how much that is. But if it has a bar on top, it's trying to ask you what it's equal to. Like what other segment is equal to it. So if you have CG and there's another one that's just like it, let's say it was AB, then you would say it's equal to AB or congruent. That's what congruent means. Okay, good. Rays. A ray is a part of a line with one endpoint only. So it's not going to have two endpoints. It's not going to have two arrows either. It's going to have one of both. Okay, so when naming rays, list the endpoint first. So rays is the one that's a little more complicated when it comes to naming it. You have to do it in a certain order. So you name the endpoint first. So the endpoint is what the starting point is on one side of it. In this case, it is point U. So we have this line stew right here, and so the endpoint we just said that is U. What other point will you use to name the ray? Well, that's not really like a question that you're supposed to answer. You could just say either of them. So I'm just going to say S. So we will just use S for this case. So if we're going to name it, we first have to put the endpoint. So the endpoint is U. Then you put the other point. So it's only two here. S. And then you have to put the arrow on top. You don't need to really put the dot here. Like with the segments, you don't really need to put the dot. You can just put the arrow. And here's the thing. So this is ray, us, ray, US. And even though the arrow is pointing left, the symbol is always the arrow pointing right. So remember that. So we're talking about going this way. You couldn't put Ray Su SU because that would act like that there's an arrow right there, but there's not. So that's important. Endpoint first, then the other one, and then with the arrow on top pointing that way. Opposite rays. These are two collinear rays with the same endpoint. So we know what the endpoint is. That's where the ray starts, where it begins. We will ask two questions when determining if it is an opposite ray. So these two questions have to be both yeses for it to be opposite ray. So if you're asked, is it opposite ray, then you have to keep these in mind. So does it have the same endpoint? And is it collinear? So if you didn't watch the other episode 1B, collinear means 2 points on the same line. So does it have the same endpoint? And are the points that you're trying to talk about the opposite ray for, are they on the same line? Okay. Let's see here. Okay. Are these opposite rays? So, well, let's actually say what are the opposite rays. So the opposite rays are OP. Oh, I made it on highlighter still. OP, ray OP, and ray ON. So remember, O is first because this is the end point right here. I mean, that doesn't mean it has to be at the end. It just means where the ray starts. So really, the two rays that you have here are this one, ray ON, and this one, ray OP. So these are the rays, not the whole thing. The whole thing is just the line. And are they opposite? Well, do they have the same endpoint? Yes. O is the endpoint. It's the same. What about, are they collinear? O and P are on the same line, and so are O and N. So yes, that means that these are opposite rays. Oh, trying to write a check. Good. What about this other one over here? Do they have the same endpoint? So let's just pretend there was two other points. I keep clicking on this. There. Okay. Let's say this is A, this is B, this is C. Okay. So the two really rays that we have here are, oh, sorry, that's not true. BA, because B is the endpoint, that's why it goes first. I was about to write AB, but that's not good. And then BC. Alright. Are they have the same endpoint? Yes, same endpoint of B. But are they collinear? The answer is no. Why? Is because A and C are not on the same line. Now, you have to remember, I meant to say A, B, and C. But when you have 2 points, any 2 points will always be collinear. But if you have more than 2, you have to check to see. And there's more than 2. So A and C could be on the same line because you could make a line that's not there. But A, B, and C, they make that shape, and they can't bend like that. So that's why that's not opposite ray. All right, more terms to know. These are the things that I was telling you that aren't rays and segments. So these are the other terms that you should know. All right, let's look at this yellow note card. Parallel lines. Well, you probably know what parallel means. These two L's, that's what parallel is. Two lines that never touch, and they just go on forever. There's nothing that can change it. They'll just keep going on. And but the actual definition when you're talking about geometry is coplanar. Remember that? That's two lines on the same plane. Coplanar lines that never intersect. And if you see a symbol that look like two L's, that means parallel. So sometimes they'll say A that symbol B, and and if it says this and you don't know what that symbol means, then it will make no sense. It just means it's A parallel to B if it had that. So like these lines right here, parallel. That seems easy enough. All right, perpendicular. This blue one right here. These are coplanar lines that intersect at right angles. And if you see this symbol that looks like an upside down T, you're talking about that. So if you see A, that thing, B, that means O is A perpendicular to B. You might already know this one, but there's just a different definition slightly. So they also have the right angles, like it says. And if you see those boxes like this, and this will be talked about maybe on the next video, but that means right angle. So there you go. And we'll talk about what a right angle is, but it is 90 degrees. You probably already know that, though. Skew lines. You might not know that one. I don't think I did. These are non-coplanar lines, so they're not on the same plane that never intersect. So that's what makes it different. That's the reason why they add in these coplanar and non-coplanar. So it's difficult to show skew lines when you're not doing it in 3D. But I try to draw this cube here, and these two lines, the yellow and blue, are examples of skew. Because if I just drew lines like this, well, they wouldn't look like they're skew because they would connect, really. But what I'm trying to say is this one is back here. It's further back. This one is going like this. Even though they kind of connect, this one's further back, so they really don't. That's what makes them skew. And if you still don't understand that, just look it up. So that's that green. All right, this pink right here, parallel lines or parallel planes are planes that do not intersect. So that's difficult to draw. So that's why I put this picture in here. If you're looking in wherever you're watching this video, look at the ceiling, look at the floor. That's coplanar planes or parallel planes. They are planes like the boards on the ceiling and boards on the floor or carpet, and they never will touch. No. Okay. Practice now. We have 5 practice questions on this video, and remember, I'll tell you to pause the video. Number 1, name 2 lines out of this figure that are parallel, and name 2 lines that are skew. And then, is it possible to have skew planes? All right, pause the video. Okay, I'll go over it now. All right, name 2 lines that are parallel. Okay. So, remember, parallel, like, for these 2 questions, there's going to be more than one answer. So, even if I say something that's not what you, thought of, that's okay, because there's more than one right answer. So, parallel means they're never going to connect, but they are on the same plane. Okay, so what I would put is, and remember when we're talking about this, these segments or lines, really, you just do this. So AD and BC, that's what the answer is. Because they're on the same plane, the plane ABCD, and they are going forever. All right, now name 2 lines that are skew. Remember, skew means not on the same plane, but they still don't ever touch. Okay, so let's see. What could an example be? Okay, here's an example. CH and FG. They might seem like they're in 2 dimensions, they look like they'll touch, but in 3 dimensions, they won't, because this one's further back. CH, FG. Now, if you see that the video is about to get to 15 minutes, I mentioned this. I have no clue how long this has been recording for, so if it cuts off, there's another video, so just watch it, okay? All right, number 3. Is it possible to have skew planes?